language waves. So bearings. Bearings are things that you would have learned maybe in the past, but it's one thing that people will forget about. So there are 3 rules that you have to follow when you're dealing with bearings. They always start and are measured from north. Okay, so no matter what you're looking at, or where from which point to which point, the angle that you're measuring is always measured from north. Unless they've told you otherwise, assume north is going straight up. Okay, so if they haven't put some kind of thing on, north goes up. They're always measured in a clockwise direction from north. Okay, so you would always measure in a clockwise direction. And they must always use 3 digits. So if your angle you measure is 87, then you would say it's a bearing of 0.87. Okay, they're the only 3 rules you need to worry about. So if you were to draw a bearing of 065, you would get your protractor out. I'm guessing that protractors. So
yes, I do.
If you have one, then let's grab it out. So let's pause this because we don't want to wait for it. So if we want a bearing of 300, how are we going to do that if our protractor only measures 180?
We draw a line all the way through so that you know half is 180 and the other half is 180.
You could do that.
Or you might do 60 degrees.
Which way though?
All the way.
So you know
Because you know clockwise.
Okay, so if you're measuring a bearing of 300, if it would normally go in a clockwise direction, then you're secretly going to measure 60 degrees in an anti-clockwise direction. So again, you're going to, for this time, you're going to flip your protractor over, so the moon is going to be on this side. You're going to have your 0 line. You're probably now going to be looking at the other scale. You measure 60, and then you show that this is your bearing of 300. Okay, so whilst you've measured this at 60 degrees, that's your bearing. Yeah, is it coming back to you using protractors? One don't we just love it? Love it. Radiant. Okay, so there we go, that's our drawing bearings. Now, if we're finding bearings, now you may be asked to do this with a protractor, you may be asked to do this using your angle geometry. So we've learned all of our angle geometry that you need to know. It says, find the bearing of A from B. So we've got 2 points here, A and B. The first thing you want to do is join those 2 lines up with a ruler. Okay, so sorry, not 2 lines. You're going to join those 2 points up with a ruler. Now, the wording of the question is important. This first question says, find the bearing of A from B. So wherever it's from is where you start with your north line. Okay? Now, if we're finding the bearing of A, it means that we're starting at B and we're going to the point where A is. So what we would be doing is finding this bearing here. Does everyone see that? Because it's from B, because it always has to be in a clockwise direction. Yes? So it's a clockwise direction from north. Okay? So you would take your protractor. Realistically, which bit are you going to measure? The small bit, because that's less than 180. So realistically, you're going to measure this portion here. You're going to subtract it from 360, and that's going to give you your bearing. Yes, you're with me? So let's pause while you do that. So be accurate. So whatever your value is, don't round it to the nearest 5 just because it looks neater. Put the actual number in. Take the big stuff.
I'm sorry, I have to get lower.
247. 247. Okay, so each person in here may have a slightly different one depending on how they drew their line. Doesn't stress too much about it. Alright, so now it says.
Did you mention the angle of?
So realistically, you could probably measure this one.
Yes.
Because you can't measure more than 180 degree. And then subtract it from 360 to find the actual bearing. So, yeah, did you measure this then?
Yeah.
What did you get? Now, okay, so this is where you need to use your common sense as well. This angle here, I can see is definitely more than 90. So it would be that you were looking at the wrong scale. Okay? But you would not be the only one that's done that later. Loads of people do stuff like that. So always check to see what the actual diagram looks like as to what your values are going to be. Okay, so next one, it says find the bearing of B from A. So this time we're starting at A and we're measuring this angle here. And we've had 067 as a suggestion. I don't know what the word I was looking for. Is it prediction as an estimate? Yeah. Proposal.
Yeah,
I 68. Okay, we've had 068 now.
I got 067.
67.
Oh, 67.
I got 68. Okay, that's fine. So when you're measuring these, if you're asked to actually measure them, they will give you a slight leeway, so maybe 1 or 2 degrees either side of the one that they believe is true. So that's why I said you've got to be accurate. Now, here's a question for you though. So I'm going to redraw this without my markers on. What kinds of lines are these north lines? Parallel lines, yes? So this angle here and this angle here are what kind of angles? Co-interior. So what's special about co-interior angles? They should add up to 180. So this angle here and this angle here should have added up to 180. Now, it could well be that whilst they don't ask you to measure, they may have told you some values. And so you're going to use angle geometry to find missing bearings. Okay, does everyone understand that? So because our north lines are parallel, we can always use our co-interior angle rules. Okay? Praise repeat answer. Now, I'll give you some questions to practice. So these are trig questions. So next page. These are actually IB trig questions. They're the first ones I found. So we may skip 1 or 2. We just need to get the idea of it. So, 2 ships leave dock at the same time. Ship A sails due north 30 kilometres before dropping anchor. Ship B sails on a bearing of 050 for 65 kilometres before dropping anchor. Find the distance between the ships when they are stationary to the nearest kilometre. Okay, what do you propose we're going to do?
Draw it out.
Draw it out. Draw a sketch of what's going on. So they're leaving dock. Okay, so I would suggest that I'm going to have my first point, my dock, down here. Ship A is sailing due north. Well, where's that? Just straight up, yes? So we draw our sketch, and he's going to finish here. That's ship A, and that is 30 kilometres. So it's a sketch. It really doesn't matter what it looks like. Ship B is sailing on a bearing of 050. Again, it doesn't matter if you draw it beautifully, but 050 means that we're going 50 degrees from north, yes? So that's around this direction. So this is where ship B is going to finish up, and he travelled 65 kilometres. Again, my drawing is not to scale, it doesn't matter though. What do I know this angle here is? 50, yes? Because that was our 050 bearing. And they want us to find this distance. Are you with me? Yeah? So is this a right angle triangle? No. No. So we're going to need to use either the sine rule or the cosine rule. Which do you propose that we're going to use for this?
Sine.
Okay. No, sine or cosine rule.
Sine rule. Because you have 2 angles and 2 lines, and you have to find out where.
Where is my other angles being?
Cosine. what I said. I don't know why.
You said tan.
Yeah, after you rejected cosine.
Well, you said sine, then tan, then cos. Like, I think you were just running through the list. You cannot say that's what I said. So, with these questions, remember you're looking to see which information you have. Jodie said very correctly, if it was 2 angles, 2 sides, you would be using the sine rule, but they haven't asked us about or told us about another angle. Our question involves 3 sides and 1 angle. Handily, we do have the angle opposite the length we're trying to find, so we can just use our cosine rule as it stands. So your cosine rule is, I use A. So A squared equals B squared plus C squared minus 2BC cos A. So that's the rule you get given. So if we're trying to find x, we would say x squared is equal to what?
Wait,
B squared. One second.
so you're trying to find.
No, that's not the area of the triangle. Remember, there's a sine rule and the cosine rule. So the sine rule and the cosine rule work for any triangle, any triangle. Yep. So this is trying to find a length. Remember it now? So x squared equals
30 squared plus 65 squared minus 2 multiplied by 30 multiplied by 65 cos 55.
you happy with that?
Perfectly satisfied.
So BC, and this is our A, and then you're going to square root that answer. You don't need to show your steps as you go. And they want the answer to the nearest kilometre, so you're going to round it to the nearest whole number. Okay, so round to the nearest kilometre, it would be 51 apparently. So a hiker leaves camp and walks 5 kilometres on a bearing of 058. He stops for a break, then continues walking for another 8 kilometres on a bearing of 103. He stops again before heading straight back. How far must you walk to get back to camp? Okay, so we're going to start again. I would also start looking at the thing and looking at the numbers before you start your point. So this is my camp. He's walking on a bearing of 058. So I'm going to draw my north line. I'm going to show it 58 degrees. And notice I haven't measured it, I've just written 58. Okay, that doesn't have to be accurate. Pardon? So this is where he stops. I know that the length of this line here is 5 kilometres. He then continues walking on a bearing of 103. Now that bearing of 103 is measured from his new location. So we're going to have to draw another north line at this point here. We're going to measure 103. Again, you don't have to measure it, but I know that it's more than 90, so I'm going to do one down here. So that there is 103. Hopefully you're all with me. Am I going too fast? How did I get this line? I just drew it.
But why?
Because he carried on walking.
But it goes straight back.
No, I've got to do this 8 kilometre distance first. This is 8 kilometres. He stops again, and then heads straight back. But you need to make a triangle, but these are all great questions. Yes. Now, did I draw this too quickly? Is everyone happy how I draw it? Yes? So, north line, and say, don't have to measure, just draw a little sketch. So, it says, how far must you walk to get back to camp? So, we're trying to find this blue line here, the length of this blue line here. You've got choices how you do this. I would say that the majority of the questions like this are going to be the cosine rule. But we need to think about the cosine rule. We've got our 2 side lengths here. This is the one we're trying to find. So we need to establish this missing angle here. So we have to look at the information we've been given and decide, are we able to do that?
Yes.
How can you do that?
Right side.
No, because this is not a right angle triangle.
Oh, okay, so then you need to use circle.
No.
Oh,
It's one of so I'm going to tell you it's also
wait. We're finding where you put the dot?
I'm finding this angle where I put the dot.
You see the,
You do use parallel lines.
we'll find out the angle
Oh!
that, gives the in co-interior stuff. You find out that one, which is 1,
Oh, and then you take it away.
and then you add those together.
Alright, so between Emily Shanty parallel lines and correctly, and Ashley's slightly further explanation, not 100%, going thingy, co-interior thingy. So if we know that these two lines are parallel, I know that this angle in here and this angle in here add up to 180. So I can find my green angle here by doing 180 subtract 58. Okay, so this one's going to be 180 subtract 58. What does that do? So this green one here is 122. I knew this black one here was 103. So that means I can find my blue one. Why? 360 subtract both of those two values. Yeah, sorry, what did you say was Emily? How much, Lee? So that blue angle is 135. Now we have a diagram similar to the one we just had a second ago, yes? So we can use our cosine rule again. So our cosine rule this time would be x squared equals 5 squared plus 8 squared minus 2 multiplied by 5 multiplied by 8 cos 135. And then you're going to square root that answer and work out. So that one is 12.1 apparently. Alright, so we're skipping this bad boy and going on to this one. Right, so ship A leaves port, sails due east. Okay, so we need to know where east is. Think you know where east is. Ship B leaves from the same port and sails 49 kilometers. Okay, we don't know which direction. The ships are then 36 kilometers apart. On what bearing would ship B sailing? Now there should be several answers for this. And depending on how you draw your diagram. So if I start my port here, and I've got my ship B leaving ship A, why am I start with B? Ship A leaves and sails due east for 28 kilometers. So I've got this as 28 kilometers. That's ship A. You can obviously, if you know your ships are 36 kilometers apart, you've got several different options here. And I would suggest either you're going to have ship B up here or ship B down here. Okay, so you've got two different options. Do you want to go up or down? Up, down, up, down, up, down, up, down. Sometimes it sounds like a nursery rhyme. Up, down, down, up. I heard up first, to be honest. So I'm going with up. So that was 49 kilometers. We'll go down then, doesn't it? And we know that this measurement here is 36. Yes.
Where it says the bearings, is in the direction of
The angle.
the same direction.
No, they say east, but they wouldn't say bearing of 090. They would presume to say east. Right, okay, so here's our diagram. Which is the best angle to find? Knowing that we're going to be needing to find the bearing of ship B. So maybe I should ask that again. So if we're finding the bearing of ship B, it's from the port, so we would have our north line going up here. So we're needing to establish this angle here. Yes, you're happy with that? So there's our north line, we're needing to establish this bearing. So which is the
One connected to 49.
Okay, wait, just question. I did mine the other way. If I did it the other way, then is that south? So I still
It's always measured from north.
so
Yours is just going to be 90 degrees. Yours is just going to be more than ours. They'll choose that.
just do it. I can't. Just do it like that.
Alright, okay. am I going to find using my sine or cosine rule?
That one.
This bad boy here. You happy with that? So I need to find this angle here. Does anyone remember the rearrangement of the cosine rule?
Which one?
I mean, which one?
Yeah, something over something.
So, cos A equals b squared plus c squared minus a squared over 2.
Oh, I made you.
So, that's one that you're going to have to try and learn or know to rearrange. So, we're going to stick these numbers into our rule. So, we're going to say that cos theta is, now, it doesn't matter which one B and C is, but which one has to be A? No. Which length is length A? Oh, length A. 36. Why does it have to be the 36? Good, it has to be across from the angle. Now, there's some people just not paying any attention. I want to make sure you're listening. So, this A here has to be the 36 kilometers. Okay? So it doesn't matter which one's A, B, and C, but the A, the one you're subtracting, has to be this one here. So we're going to have 49 squared plus 28 squared subtract 36 squared over 2, 49, 28. And then to find theta, you're going to have cos to the minus 1 of that answer. And we're going to find an angle. Right, how much they said we've got 46.5 as our angle, but they asked us about the bearing, the black bearing. How are we going to work that out?
90.
Why 90?
Because something.
Good, because if you remember, little old ship A travelled on a bearing east. So we know that this angle here has to be 90 degrees. So if this bit here is 46.5, then this bit here is going to be 44.5, but it's a bearing, so we would say 0, 4. Oh my gosh, yes. Emily.
Emily, you did that?
Miss Harrison, can you go up to the people who are upside down?
No.